Welcome. Let's discuss the angle measurement of radians. Let's start by considering the circle on the left with the center at O. Now let's choose a point in the circumference of the circle. Let's choose this one. Now if we connect those 2 points, we will define the radius of the circle. Now the radius that we have just defined here, it definitely has a length to it. What if we get that length and we go on the circumference of the circle? So to illustrate this idea, let's say that the radius of the circle was of 3 centimeters. Well, what if we travel 3 centimeters on the circumference of the circle? When we do so, we have an endpoint. When we connect this endpoint back to the center of the circle, which is the radius, notice that we are defining an angle between the opening of those 2 radiuses. And the measurement of this angle is what we refer to as 1 radian. By definition, we can say that a radian, it is the angle that is created when the length of an arc is equivalent to the length of the radius. Let's visualize another radian. If we look at the length of the radius, and we go around the circle by that much of a length, we define a radian. So therefore, if we start at this point, and we travel the same length, we can define another radian. Let's connect that endpoint to the center of the circle, and the angular measurement that we have here, it's of a value of 1 radian. So what we have here, it is the value of 2 radians, one after the other. We can go around and cover the whole circumference of the circle. And that's our next question. How many radians can we create in a circle? Well, notice that if we were to go around this circle, we will be covering the whole circumference of the circle. But let's use the formula of the circumference of the circle to answer this question. For the circumference of the circle, it is equal to 2 pi times the radius of the circle. Let's pay close attention to the radius of the circle in this equation. When we consider the radius of the circle, we have said that when we travel that same length of the radius of the circle, we create an arc. And when we travel that much of a distance, we create 1 radian. If we were to consider the length of the radius one more time, and we travel that much distance around the circumference of the circle, we would have created another radian. So notice that as many times we can fit the radius on the circle in the circumference, that will tell you how many radians you can create on the circle. That if we go around the whole circle, that will be equivalent to 2 pi radians. What we have shown here is that if we go around the full circle, we would have created a total of 2 times pi radian. Well, remember that pi, it's approximately 3.14. So we have about 2 times 3.14 radians, which is about 6.28 radians. Regardless of how big or how small your circle is, when we go around the circle, we will always gonna be able to fit 6.28 radian. We don't usually just keep it in terms of 6.24 radian. That's an approximation, but we always leave it in terms of pi. We can say that we have 2 times pi as many radians within a circle. So we have shown that in a full circle, we can fit 2 times pi as many radians. So how many radians can we fit in just half a circle? We have already established that in a full circle, we have a total of 2 times pi radians. So if we're interested in half a circle, that will be the same as taking half of the measurement that we have for radians. The 1/2 will cancel out with the 2. So now we have our conclusion. in half a circle, we have a total of pi radian. And to visualize this result, remember that pi has an approximation of 3.14. So what we're saying here is that we can fit approximately 3.14 radian. So that will be 1, that will be 2, that will be 3, and a very small portion of 0.14 of the next one. So now that we have shown that radian is a measurement of angles as well, what relationship does radians have with degrees, which is another measurement of angles? Let's discuss that. There are two main ideas that we have discussed. In a full circle, we have a total of 2 pi radians. And also we have said that in half a circle, we have pi radian. Let's remember that also in half a circle, we have 180 degrees. If we combine these two ideas together, now we can say that 180 degrees is equivalent to pi radians. And using this relationship, we can figure out what's the value of 1 radian in terms of degrees. Because in the equation on the left, if we divide by pi on both sides, now we can say that 180 divided by pi degrees, it is equal to just 1 radian. And the other way around, if we were to divide it by 180 on both sides, now we can say that 1 degree, it is equivalent to pi over 180 radian. And this is how we define the conversion factor between radians and degrees. If we're given an angle in terms of radians, and we want to express it in terms of degrees, we gotta multiply by this scale factor. And if we're given an angle in terms of degrees, and we want to represent it in terms of radians, we gotta multiply by this scale factor. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.